Hi students, class 6 IIT Math. So today we shall see the second chapter, whole numbers. Let's check. So in this chapter, what shall we learn? So please check the screen. You can see the screen. So definition of a natural number, introduction to zero, whole numbers, successor, predecessor, even numbers, odd numbers, properties of natural numbers and whole numbers, under addition and subtraction, properties of natural and whole under multiplication, natural numbers and whole numbers under division. So let's see. So here, definition of a natural number. Generally, we can say the natural numbers like 1, 2, 3, 4 are counting numbers. From our childhood onwards, we are learning all these numbers. Counting numbers are said to be natural number. Natural numbers denoted by the letter N. Smallest natural number is 1 and biggest natural number we don't know. So here predecessor and successor. So there is no predecessor for 1 in the natural number because we get 0. That is not there in the set of natural numbers. And successors we have. Right. Let's go for the next. Here we have introduction to 0. So the word 0 is a translation of Sanskrit word shunya, which is an empty. The first known English use in 1598 denoted by 0. So generally in our Indian language, like in Sanskrit, shunya. Shunya means what? There's nothing, emptiness. So emptiness in mathematics we denote like 0. If we add 0 to the natural numbers, obviously we will get whole numbers. So 0 to the counting numbers, we will get the whole numbers, right? So denoted by the letter W, and smallest is 0 and the biggest we cannot define. And successors. Here you can see successors and predecessors of whole numbers. 0 is 1, 99 is 100, 125 is 126, 200 is 201, 999 is 1000, like that. And then predecessor. Predecessor means the number which we count like subtracted 1 from the given number. So here 1 in the natural numbers, we don't get the predecessor of 1, but in whole numbers we will get the predecessor of 1. Predecessor of 1 is 0. Okay, 1 minus 1. Likewise, 10, 100, 125, 200, like that we will get all these numbers. Then next. Yeah, see here. The number 1 has no predecessor in set of natural numbers. The number 0 has no predecessor in the set of whole numbers. Smallest and highest, all these we know. And smallest one-digit number is 1. And biggest one-digit number is 9. Smallest two-digit number is 10. And biggest two-digit number is 99, like that. So even numbers. The numbers which are natural numbers which are multiples of 2 are divisible by 2. We can call as even numbers. So 0, 2, 4, 6, 8 at the ones place are called even numbers, right? Here are some properties, just go through. So general form of an even number is 2n. The sum of an even natural number is n in 10 plus 1 or n square plus 1. So 2 plus 6 plus 4 plus 6 and so on, right? Odd numbers, 1, 3, 5. So the numbers which are not divisible by 2 are called odd numbers. Okay. So see, 3 plus 5 is equal to 8. The sum of two odd numbers is even. Even the difference of two odd numbers is also, two consecutive odd numbers is also even, right? So these are the properties we can see. Just go through this. Next, general form of an odd number, 2n plus 1 or 2n minus 1. An even number is 2n. The sum is there, n square plus n. Here only n square. The next. So we have some properties under multiplication. Closure, commutative, associative, multiplicative identity, distributive property. Zero property. Let us check these properties. So in this sequence, We are checking for natural number and whole number. For any two natural numbers, A into B is also a natural number. A into B is also a whole number. Commutative, associative, and multiplicative identity, right? And distributive property under multiplication or addition. So let us check this on the board. Yeah, you can see the board. So properties of whole numbers or properties of numbers. Properties of numbers. We'll see natural numbers and whole numbers here. So first closure property we'll check. Closure property. Closure property. So if A comma B A comma B are any two natural numbers, then A into B is also a natural number, right? A into B is also a natural number. That means let us take an example. 1 comma 2 natural number. 1 into 2. 1 into 2 is how much? 2 is a natural number. I will take some other numbers. 2 comma 3. 2 into 3 is how much? 6 is a natural number. Like that. Suppose let us go for the whole numbers. The whole numbers. Zero comma 2 are two whole numbers. 0 into 2 is equal to 0 is also a whole number. 0 and 15. 0 into 15 is equal to 0 is a whole number. So natural numbers and whole numbers are closed under multiplication. Are closed under multiplication. Natural numbers and whole numbers are closed under multiplication. Next, we'll check for commutative property. Commutative. So here A comma B are belongs to either natural numbers or whole numbers. A into B is equal to B into A. That is the property. So likewise, we will take go for natural numbers first. Let us choose any two natural numbers, 2 and 5. Next, 2 into 5 should be 5 into 2. 2 5s are 10, 5 2s are 10. So let's go for the whole numbers. 0 into 5, 5 into 0. We get both are 0. So commutative property holds in natural numbers and whole numbers under multiplication. Or else we can say like natural numbers are commutative. Commutative under multiplication. Under multiplication. Right? So likewise, we will go. And then And then whole numbers also same property will come. Whole numbers are commutative under multiplication. So closer commutative. Next, associative property we will check. Associative. Associative under multiplication. Let's check for A into B into C. A is equal to A into B into C. Just check it out. A into B into C is equal to A into B into C. So let's take any two numbers. Two not, three numbers we have to take. 1, 2, 3 from natural numbers. 0, 5, 6 from whole numbers. Okay. 1 into 2 into 3 is equal to 1 into 2 into 3. 1 into 6 is equal to 2 into 3. 6 is equal to 6. LHS is equal to RHS. Hence, natural numbers are associative under multiplication, we can say. The same we can take for whole numbers. 0 into 5 into 6, be unseen one bracket. 0 into 5 into 6. So we get 6 5s are 30 and 0 into 30 is 0. Yet 0 into 6 is 0. So it is equal to RHS. So we can say that whole numbers are associated under multiplication, right? So in this way, we can check all these properties. So let's have a look once again. Yeah, just see this. Associative property we have completed. Both whole numbers and natural numbers. Multiplicative identity. Yes, multiplicative in that sense, we should get the same answer. A into 1 is equal to 1 and A is equal to A. And like in both natural numbers and whole numbers, same answer we have to get. And distributive property under addition or multiplication, like A into B plus is equal to A into B plus A into C. And A into B plus is equal to A into B. The rules, whatever will come for natural number, the same will come for whole numbers. Zero property. Zero property in the sense we don't have 0 in the set of natural numbers, so that we can't say A into 0 is equal to 0 and A is equal to A. Right? So like this properties will come. Let us see some more what we have discussed here. Yes. So for any whole number, A divided by 1 is equal to A divided by 1 is equal to A. And 0 we can't. A divided by 0 is not defined. Okay. 23 whole numbers, A B divided by A is equal to X, means B by A is equal to X. And fourth one you can see division by 0 is not defined. 7 divided by 0, 7 divided by is equal to, it's not defined, right? Like that. When 0 is divided by any non-zero whole number, the quotient is always 0. 0 divided by A is 0, but A divided by 0 is an undefined value. So these are the points what we have seen still now. Let's go for the objective type. Okay, let us check some objective type here. See some questions from 1 to 5. The set of natural numbers is denoted by. The set of natural numbers is denoted by the letter N. Second one, all natural numbers are also whole numbers. Yes. 1 is the smallest natural number. Yes, both are correct. Because whole numbers are starts from 0 and natural numbers are also included. 0 and natural numbers are together are called whole numbers. That's what both 1 and 2 are correct. Which natural number has no predecessor? Yes. Which natural numbers has no predecessor? The number 1 do not have any predecessor, because One predecessor comes as 0, but 0 is not exist in the set of natural numbers. How many natural numbers are there? 100, 1000, infinitely many, 10. How many natural numbers are there? Yes, infinitely many, because there is no end for natural numbers. The correct statement in the following: n is equal to w, n is subset of w is subset of n, can't say. Always we go for n is subset of w. Natural numbers is a subset of whole numbers. And 6, the line on which we represent the natural number is known as. The line on which we represent the natural number is known as. What is the natural number line? Yes, we can say number line and counting line. Both are correct. And question 7. Question 7 is, yeah, the sum of n natural numbers, n into n plus 1 by 2. n into n plus 1 by 2. Next, let us continue. Let us see this. So here, the sum of first n odd natural numbers. The sum of first n odd natural numbers is n square. Even is n square plus n. Just now we have seen that. And when natural numbers and 0 put together, the new set is called whole numbers. No? Yes, it is a whole numbers. Whole numbers are denoted by the letter W. The smallest whole number is 0. The number which is neither positive nor negative is also 0. 0 we can say not positive and not negative. Not positive and not negative. Next. Successor of 1, 2, 4, 3. Successor of 1, 2, 4, 3 is how much? Successor and predecessor. Successor in the sense plus 1. Predecessor in the sense minus 1. Okay. So successor 1, 2, 4, 3 is 1, 2, 4, 4. And successor of a given number is located on dash side of the given number on the number line. See, successor means next number. Next number always will come right side of the number line. Predecessor of 236. Predecessor of 236. 236 minus 1 is 235. Next, 17. Successor or predecessor of every even number. Successor or predecessor of every even number. In the sense, even number, 2 I will take. 2 plus 1 is 3. 4 plus 1 is 5. So, and 2 minus 1 is 1. 4 minus 1 is 3. The successor and predecessor of every even number is odd number. Like that it will go. Right. Successor of 0 in the set of whole numbers. So 0 we don't have any successor. Sorry, successor means next number. 0 plus 1 is 1. Predecessor we don't have. The product of a non-zero whole number and its successor is always non-zero. Non-zero means take 1 or 2 or 3. I will take 2 and its successor. 2 successor is 3. 2 3 is a 6. 2 3 is a 6 is an even number. And one more example we will take 3 and 4. 3 4s are 12. Even number. And also is divisible by 3 also. Both options are correct. I will go for 5. 5 successor is 6. 5 6 are 30. It's an even and also it's divisible by 3. And 21st question. Predecessor of a natural number 1. So we don't have 0 in the set of natural numbers. So that there is no predecessor in the set of natural numbers. Does not exist. Next. Predecessor of which 3-digit has a 2-digit number. Predecessor of which 3-digit has 2-digit. Predecessor in the sense like before number we shall write. Here some examples are there. 3-digit number starts with 100. 3-digit number starts with 100. Then 100 minus 1 is 99. So predecessor of 3-digit number 100 is 99. So once we go through these questions, what we have discussed now, just check it out. So these are the questions. Next page will go. This. The smallest value of n which is even prime is. Even prime. So prime numbers are starts with 2. So we do have even prime is 2. The smallest value of n which is not a prime. Which is not a prime in the sense n. Here n is what? Even or odd will take. Even odd number 3 and greater than 0. We go for greater than 0. The product of two even numbers. 2 4s are 8. 4 6 are 24. 2 10s are 20. We multiply two even numbers, we will get even number only. Okay. Next. Difference of even and odd. Even and odd. 5 minus 4. 1. 6 minus 2. 6 minus, 7 minus 2. 5. So difference of even and odd, we are getting odd number. If the sum of two natural numbers is even, then the difference is sum of two natural numbers in the sense two natural numbers. Let us take 2 plus 4. 2 plus 4 is 6. The difference is 4 and 6. 4 and 2 difference is 2. I'll go with 8 and 4. 8 plus 4 is 12. And 8 minus 4 is 4. So sum of two natural numbers is even and difference is also even. These are like logical thinking questions. Problems on properties of natural numbers and whole numbers under addition and subtraction. Just go through this. Let us go through these sums. The property related to the given operation 7 plus 0, 0 plus 7 in the set of whole numbers. 7 plus 0, 0 plus 7. Here order is changed. So what can we say? A plus B is equal to B plus A. It is a commutative property. We'll call it as a commutative property. 29th, 38 plus 83 plus 38 is equal to 38 plus 83 plus 38 is an example of. It's an example of, yes, associative property under addition. Next, sum of two natural numbers is natural number. Sum of two natural numbers is natural number. 2 plus 1 is equal to 3. 5 plus 6 is equal to 11. It is a closure property. Whole numbers are closed under which operation? Whole numbers are closed in the sense, let us take two whole numbers. 0 plus 1 is 1. And 2 plus 3 is 5. 2 plus 3 is 5. So we can say addition or subtraction we don't get, and division also we don't get. Only addition we will get. Only addition we will get. Let us check the question. Next question. Which number is identity for addition of whole numbers? Which number is identity for addition of whole numbers? So which number is identity for addition of whole numbers? In the sense, identity, if we add any number to the given number, the value should not be changed. Like a plus 0 is equal to 0 plus a is equal to a. So identity for addition, that means 1. If I add 1 for any whole number, the value will be changed. 2 also. But 0 if we add to any number, like in the whole numbers, 100 plus 0 is equal to 0 plus 100 is 100. So 0 is called additive identity. Additive inverse of 7 in natural numbers. So there is no additive inverse in the natural numbers because there are no negative numbers in natural numbers. Okay. So that -7 is not present in the set of natural numbers. We can say does not exist. So hope you follow this. Up to 35 questions we have checked. Let's recall once. Let's check it out. Yeah, let's go for the next page. That is the next page. Yes. Multiplicative identity in the set of whole numbers. Multiplicative identity. That means let's multiply a number to the given whole number. The value should not be changed. Which one? Obviously 1. 1 into 2 is equal to 2. 1 into 100 is equal to 100. 1 into 0 is equal to 0. So answer is B. Multiplicative identity in the set of whole numbers or natural numbers, both are same. Next, commutative property of multiplication in whole numbers is represented by. Commutative property of multiplication in whole numbers is represented by A into B is equal to B into A. Suppose that is addition, will go for A plus B is equal to B plus A, and subtraction A minus B is equal to B minus A. Multiplication, it was clearly given. Next, problems on properties of natural numbers and whole numbers under division. Division by 0. Division by 0, it's not defined, right? A divided by 0. Next, add the quotient of 750 and 15 to the difference of 75 and 33. So let us do this sum in the board. Okay. Question 40. Yes, I'll open the board, then we'll do this on the board. Right. Add the quotient of 750 and 15. Question 40. Add quotient of 750 and 15. And then to the difference of 75 and 33. Quotient means we have to divide, right? Let's divide. 15 5s we'll check. 5 5s are 25, 5 1s are 5, plus 2 7. So 50 will come here. So the quotient of 750 and 15 is 50. And the difference of 75 and 33. Subtract this, 7 minus 3 is 4, 42. So now we shall add these two numbers. Which two numbers? 50 and this 50 and 42 we have to add, right? +50 plus 42 is 92. Answer is 92. Option C is correct. Okay. The next question also I will read. Divide 120 by the product of 4 and 3. divide 120 by the product of 4 and 3. So product is what? 4 3s are how much? 12. Let's divide 120 by 12. Okay. So that's how much we will get? 10 is the answer. Right? So like this. So these are the questions what we have done now, 40 and 41. Okay. 40, option C is correct. And 41, 10 is correct. Okay, no? Like that. Next. Which of the following statements is false? All natural numbers are whole numbers. Yes, it is correct. It is true. All whole numbers are natural numbers. No, because 0 is not a natural number. 0 is not a natural number. The predecessor of two-digit number is never a single digit. Yes. Predecessor of the smallest two-digit number. See, it is the all whole numbers are natural numbers is wrong. And the predecessor of a two-digit number, I will take 10, I will take -1. 10 minus 1 is how much? 9. Single digit only coming in. So this is also false. This is also false. 1 is the smallest whole number. False, because 0 is the smallest whole number. Like this. Right, next. These are the following statements incorrect. Incorrect or false, both are same. The natural number 1 has no predecessor. Yes, it is correct, because natural number predecessor is 1, if predecessor is 0, it does not exist in the set of natural numbers. The whole number 1 has no predecessor. It's wrong, because 0 is there and 0 is the set of whole numbers. The whole number 12 lies in between 11 and 13. The whole number 12 lies in between 11 and 13. Yes, it is correct. 12 will be in the middle of 11 and 13. The successor of two-digit number is always a two-digit number. So successor two-digit, I will take 10. 10 plus 1 is 11. And 99 I will take. 99 plus 1 is how much? 100. The successor of two-digit number is always two-digit number is wrong. Except this case. Except this case. This is also false. B and D are false. Okay. Hope you have followed. Right. 43 questions completed. Let's go for next question. Yeah. Let us complete this matching and we'll end up this class. The difference of two consecutive whole numbers. Two consecutive means let us take 2 and 3. What you will get? 1. So first one is R. The product of two non-zero consecutive. Same numbers you take. 2 3s are how much? 6. What you will get? Even. Quotient when 0 is divided by another non-zero whole number. Quotient when 0 is divided by another non-zero. Always will get 0. 0 divided by any number is 0. 2 is added 3 times to the smallest whole number. The smallest whole number is 0. 2 is added 3 times. 2 3s are 6. 0 plus 6 is 6. Answer is yes. And smallest odd prime. Even prime is 2. Odd prime is odd only. Right? The first one is R. 2 consecutive 1. The difference of two consecutive whole numbers. Let us take for 5 and 6. 6 minus 5 is equal to 1. First one is 1. But here options are given like different. They give P like. Because 1 is also odd number, we can consider P also. Right? P also is correct because 1 is an odd number. And product of the next option T. And T And next option, third one is a Q. Yeah, Q is correct. And fourth one is S, fifth one is R. Okay. And 2 is 2 added 3 times to the smallest whole number. So fifth one we don't get 1 because you'll get here, sorry, fourth is S and fifth one, smallest odd prime number R. Smallest odd prime. But 1 is not a prime. Don't go for this one. 1 is not a prime number. Prime number starts with 2. 2, 3, 5, 7, like that. So this is what whole numbers we have discussed today. 50 questions in chapter 2, and also some some concepts based on the whole numbers. So hope you have followed. So shall continue the same topic, same objective type, the next section. Thank you.